Okay, so I'm just going to start with the very first example he gave us because it kind of went downhill from there. So he gave us this chemical reaction and he told us that it is an acidic reaction, which lets us know that later on we're going to have to balance charges with H plus and H2O, as opposed to a basic reaction in which you'd have to balance charges with OH minus and H2O. So the first step is to break it into its half reactions. So to find the oxidation reaction, we're going to have to use our acronym oil rig. So we know that oxidation loses electrons and reduction gains electrons. So that lets us know that the I minus going to I2 is going to be our oxidation because it lost that electron to get to I2, which is going from a negative charge to a neutral charge. And then the reduction reaction is a little more difficult to use that specific acronym for, but we do know that reduction reactions also lose oxygen, and we see that happening here with MnO2 going to Mn2+, so that's going to be our reduction reaction. Okay, so the second step was to balance the central atom. So for the oxidation reaction, on the right side, it's given to us that it's I2, so we know that we're going to have to use the coefficient 2 to balance that I minus and have 2 iodine atoms on each side. And then for the reduction reaction, our central atom is going to be manganese, and it's actually already balanced because it's already 1 in 1, so you don't have to worry about that. Okay, so the third step was to determine the oxidation numbers, and I know this was a little more difficult for some, so I just kind of broke it down into the steps rather than kind of just doing it like he did. So for the oxidation reaction, you see that the negative charge of iodine is basically our oxidation number, so it's given to us. So our oxidation number is -1, and then the neutral charge of I2 is going to be our oxidation number, so it's going to be 0. So those are given to us. You just have to pay attention to when you see certain charges. And then for the reduction reaction, the same goes for the right side of the reaction, the Mn2+, our oxidation number is going to be +2. But the left side of the reaction is going to require a little more math because you have that oxygen, the 2 oxygen atoms, so you're just going to have to kind of take those into account. So basically, to find what the oxidation number for manganese would be on the left side of the reaction, you would take the oxidation number of manganese plus the oxidation number of oxygen, which would give you your total charge. And we know that our total charge is 0 because the molecule itself is neutral. And then I think somewhere in the book he gave us rules to determine, rules that are like basically some known oxidation numbers. I don't know where in the book it is because I kind of just have some of them memorized from AP, but if you guys want to like try to find where those are, that can help you. But we do know that for oxygen, the oxidation number is -2, and it's kind of like a little hint because you know that your oxygen ion is a -2 charge, so that can kind of help you remember that. And then we see that there are 2 oxygen atoms, so basically you take that -2 oxidation number, multiply it by those 2 oxygen atoms to give you a total charge of -4. And then X being our variable for our oxidation number for manganese, you find X minus 4 equals 0, and that gives you X equals +4, so our oxidation number for manganese is +4. Okay, so the fourth step was to determine how many electrons are gained and lost. So again, we know from oil rig, oxidation loses and reduction gains, but just to find the specific number, we found above that the oxidation number for iodine on the left side was -1, and we know that there are 2 iodine atoms or ions, so we know that you have to take that -1 times 2 to give you a total charge of -2, and on the right side we know that there's already a 0 or neutral charge. So basically, to go from that -2 to that neutral charge, you had to lose 2 electrons, and that's why you place it on the right side of the reaction to show you that 2I- lost 2 electrons to become I2. And then for the reduction, we see that it went from +4 to +2 from our oxidation numbers above. So that lets us know that we had to gain 2 electrons, which is why it's placed on the left side of the reaction, because you had to gain 2 negative charges to get you from a +4 charge to a +2 charge. And then the next step was to balance the charges with H+ or OH-. And again, we know that it's an acidic reaction, so it's going to be with H+. So for the oxidation reaction, the charges are actually already balanced because you have the 2 negative charges for 2I- and the 2 negative charges for 2E-. So those charges are already balanced, so you won't have to add any H+. But for the reduction reaction, the charges are not balanced because you have the 2E- charge on the left side, so a -2 charge on the left side, and you have a +2 charge on the right side. So you're going to have to find a way to get that overall charge balance, and that's why you add 4 hydrogens. So basically X plus -2 equals +2, and that gets you X plus 4, which lets you know that there are going to be 4 hydrogens. Okay. And the 6th step was to balance the hydrogens with water. So there are 4 H+ on the left side, which lets you know that you're going to have 4 hydrogen atoms on the right side. So it's going to be 2 water molecules because 2 times 2 is 4. And then kind of like he pointed out, but he was just making it seem like, oh my gosh, oxygen balances out, and he's not really like explaining it. There are 2 oxygen atoms on the right side to balance out the 2 oxygen atoms on the left side for the MnO2. So that's why those balanced out. And then the last step was to balance the E-. And he was just kind of showing that it's kind of already done, you just have to cancel it out. So for the oxidation reaction, there were 2 E- on the right side, and for the reaction, there were 2 E- on the left side. So if you think about the arrows as like an equal sign and you were adding those 2 equations together, the 2 E- would cancel out because they're on opposite sides of the equation. So that lets us know that our final balanced equation is going to be 4H+ plus 2I- plus MnO2 goes to I2 plus Mn2 plus 2H2O. And then our N is going to be the 2 E- because those are the amount of electrons that were lost and gained and that were canceled out. I hope this helped. I'm sorry, I'm not the best teacher, and I'm not good at just teaching in general because I'm really awkward, but I really hope this helped because I really feel like he could have done a better job at explaining. So yeah.